Welcome to our Data Warehouse Designer video tutorial. Prognoz Platform provides a fully integrated toolkit that allows you to set up and customize data warehouses in order to perform business analysis tasks. Data Warehouse Designer supports relational, multidimensional, and file structures. Prognoz Platform allows you to set up multidimensional data warehouses using the bottom-up or the top-down approaches. If you need to design data warehouse structure on your own, choose the bottom-up approach to create dictionaries, multidimensional cubes, and so on. The bottom-up approach provides for easy integration with other information systems without data duplication. Connect to external sources, such as accounting and management systems, to use provided data for creating dictionaries, cubes, and reports. If you use the top-down approach, a physical data structure is designed automatically. It allows users to create different repository objects without having to worry about physical structure implementation. When developing a data warehouse, you can combine these two approaches. Let's consider developing a data warehouse using the bottom-up approach. Data is physically stored as a relational structure on the database management system server. To access the DBMS objects and their data, we create a special repository object, the database. To create objects, we use a set of visual wizards. On the first wizard page, we define the basic properties of the object, namely its name and identifier. The next page of the wizard allows you to override the database connection settings. Prognoz Platform uses database object to connect to any modern database management systems. This allows easy integration with external systems data warehouses. Let's use the default parameters similar to repository connection properties. Database management system server connection can be established automatically using login credentials. Upon wizard completion, the created database appears in the navigator. At the physical level, the platform uses relational structures, tables. Let's create a new table. Prognoz Platform objects have a list of parameters providing dynamic modification of their content. These parameters are defined on the corresponding wizard page, but in our case, we do not need them. Prognoz Platform allows you to choose from 5 table types, each having specific settings. A table and view create the corresponding objects in the database. An attached table links an existing database table. It can be used to access data from another system. A query defines an SQL expression that is executed when the query is opened. An ODBC data source connects to external data source using an ODBC driver. Attached tables and ODBC data sources facilitate and speed up real-time data integration with other systems. Let's use the standard table and specify the database for it. Then, add table fields. The key contains unique identifier of a territory. The name, the owner, that will be used to create a hierarchical dictionary based on this table, and the order. You can define type and constraints for each table field, including total length, null value support, and so on. Indices and a primary key can be used to speed up, select, and sort operations. Let's create an index based on the key field. Note that this index is the primary key of the table. Moreover, you can define a number of constraints and triggers, but in our case, we do not need them. A countries table appears in the Object Navigator. You can input data into the table manually or load data using an ETL task. This table will be used as the basis for a hierarchical dictionary of countries. So we load elements that contain a hierarchy through the ETL task, the continents, and the countries. With Prognoz Platform, you can create a variety of dictionaries. By way of example, let's create the countries dictionary. The following basic types of dictionaries are available. Table dictionaries are created using the bottom-up approach. These dictionaries support manual configuration. To build a table dictionary, create a new table or connect to an existing table in the repository. In addition, the platform supports table MDM dictionaries that are created using the top-down approach. When you create a table MDM dictionary, its physical data structure is created automatically. One more type is the calendar dictionary. Its structure and content are generated automatically based on the settings defined upon creation. A calendar dictionary is used to process time-dependent data. The content of a calculated dictionary depends on a user-defined algorithm in the for language. Now, let's create a dictionary using the bottom-up approach and the countries table. You can create a table dictionary in 2 modes. The first is simple mode. where you specify only the basic settings and the source. The internal structure of the dictionary is created automatically. And Advanced Settings. This way, you create the dictionary structure and specify a data source by yourself. By default, the dictionary is created in Simple mode. But since we need a hierarchical dictionary with an additional attribute, we select Advanced mode. On the next page, we define dictionary attributes. Advanced mode sets the following default attributes: name, identifier, and order. Simple mode displays only the attributes specified in the user-defined data source. You can edit or delete a selected attribute. In addition, you can specify additional attributes that can be used. For example, implement a hierarchy or control versions of dictionary elements. Please note that the corresponding Add button is active only in Advanced mode. In Simple mode, you can add new attributes only when you delete one or more attributes. As we're going to create a hierarchical dictionary, let's add a new attribute named Owner. On the next page of the wizard, we define attributes for sorting dictionary values. The Order attribute is selected by default. Now, define the dictionary structure by creating general and recursive blocks. General blocks are used for linear dictionaries, or if an exact number of hierarchy levels is known. If the number of hierarchy levels is not defined, recursive blocks are used. Add a recursive block to the dictionary and bind the primary key of the block to the identifier. Also, add a primary index to the dictionary. Dictionary indices are used for data binding when creating multidimensional cubes. When the dictionary structure is configured, let's bind table fields and dictionary attributes. As we've created a recursive block, we need to define the recursion condition using the formula editor. Now we specify the condition to define the elements of the upper hierarchy level. The formula editor of the Prognoz platform supports expression validation and IntelliSense auto-completion. Let's select the null value of the owner attribute for the upper level elements. Now, let's define how to bind the child and parent elements using the owner field. The next stage requires you to specify the list of dictionary levels to be used in data aggregation. For hierarchical dictionaries, separate names can be specified for each hierarchy level. Dictionary setup is completed, and we click the Finish button. The created dictionary is now available in the navigator. As you can see, the structure of the dictionary is hierarchical, and it contains data from the countries table. Let's create a cube. Open the Data Sources folder and select the corresponding item in the navigator menu. Specify the name and identifier of the cube. Prognoz Platform supports 5 different cube types: a standard multi-dimensional cube, a view cube, obtained by fixing certain dimensions of source cube, a virtual cube obtained by combining several cubes, a calculated cube, which values are calculated according to their user set formulas based on the values of other cubes, and an automatic cube that is similar to a standard cube, but uses the top-down creation approach. Select the standard cube. Specify the cube facts. You can either define facts for each cube locally or use an existing dictionary. Define facts for the cube locally. To do so, create new fact named value. Once the list of cube facts is defined, they should be bound to corresponding table fields. For example, let's use the socioeconomic data table. Bind the value fact with the corresponding table field. Next, you need to specify the cube dimensions and bind dictionary's attributes to the table fields. For example, let us add the calendar dictionary to the list of dimensions. Once the dictionary is added, bind it to the data table. Let's use annual data. To do so, choose the primary index of the corresponding block of the calendar dictionary. Similarly, you can easily add indicators and countries dictionaries to the list of cube dimensions. Other wizard pages allow you to automatically convert factors to different units, customize relations and formulas for calculated cube facts, set up relations between cube parameters and its objects, aggregate cube data by levels of various dictionaries. For the purposes of our example, these properties are not necessary, so finish the cube creation. To view the contents of the cube, use the OLAP analysis tool. Once dimension positions are specified and appropriate selections are made, the table shows the chosen data. This was a short overview of designing a data warehouse using the bottom-up approach. Creating data structures using the top-down approach is possible with the time series database. It's designed to manage and analyze statistical data. Unlike cubes, time series databases provide additional services such as data revision, validation, and transformation. To create a time series database, specify the NDN repository and dictionaries of measures and units. You can select existing dictionaries or create new ones. Further wizard pages allow you to define attributes and indices for the time series database. Create new country attribute, bound to the corresponding dictionary. Select necessary calendar levels. The internal structure of the time series database is created automatically. Now, data for analysis can be imported into the database. The created objects can be used when delivering Prognoz Platform reports. Thus, Prognoz Platform Data Warehouse Designer allows you to easily create data warehouses of any architecture and complexity by creating data structure from scratch or by connecting to existing systems. Our Data Warehouse Designer video tutorial is over. Thank you for your attention.